Okay, college algebra. Welcome to problem 19 on the practice final. Essentially, you're going to be given a three variable, three equations, system of equations, and you're asked to solve. You're not told which way, which how. It's up to you. There's at least half a dozen ways probably that we talked about it. And you can use any method you want. I'm not going to try to go through every single possible method of solving this. Since the curriculum is kind of heavy on matrices, I'm going to go ahead and use Gauss-Jordan, just because you don't have to. You could use some traditional methods, like the elimination or linear combination. Maybe get it down to a two-variable system, then use Gauss-Jordan, or then use Cramer's rule, or then just keep going with the elimination. It's all up to you. It doesn't really matter. Show your work. Show me what you were doing. And certainly when you're done, you want to come back and check your answers. Make sure that they're matching up. And then when you plug in the x, the y, and the z in the first equation, if you don't get 24, start over. Plenty of time to work on the test. So let's just dive in. Remember, we're going to take the coefficients. We're going to take the 4, 4, 1, 24. It's an augmented matrix. 2, negative 4, 1, 0. 5, negative 4, negative 5, 12. So those all the coefficients and numbers. And remember, what we're going to do is we're going to apply our rules of the game. We can add a row to another row. Seemingly we can subtract a row from another row. We can multiply a row by a number. We can swap rows. We can do combinations of these things. So we can multiply a row by a number, add or subtract it to another row, and then we can swap them around and then swap that one that we multiplied by something back to its original form, because it's the same thing as multiplying by its inverse. So all these things are possible and easy. This is more accounting. You just got to be careful at every step. So remember that our goal is to end up with something that looks like this. And so if we can make this matrix look like this one up here, then these numbers that end up over on the right column are essentially the solutions to x, y, and z. Okay? So here we go. Where to start? Let's do this. If I take the first row and subtract it from this third row, I will get a 1 here, because 5 minus 4 is 1. How cool is that? And doesn't look like it's going to help us anywhere else, but at least I have a 1. And then I think I can figure out how to go for a 0 somewhere. And if I can get maybe this first, I want to either kind of work this way or this way, kind of, so we'll see. But once I make this a 1, whatever these are, I think I'm going to move this to the top row. And that's just because this 2 and the 4 have easier possibilities for making a 0 somehow. And you could be looking at this going, hey, Mr. Massey, you really messed up here. You should be doing it a much easier way. But hey, this is kind of the way I'm seeing it, so that's the way I'm going to do it. So 5 minus 4 is 1. Negative 4 minus 4, negative 8. Negative 5 minus 1 is negative 6. And then 12 minus 24 is negative 12. Okay. Now, like I said, I'm going to move this. I'm going to do a swap, where I'm going to swap this last row up to the top. And then I'm going to, and 2, negative 4, 1, 0. Okay? Okay, so here we go. That may not look like we've made a whole lot of progress, but we've done something. We've done something. Okay, so let's do this. And I'm going to kind of combine steps here. I think you've done this enough. You can break it down into separate steps if you want. But now that I have this 1 here, I can subtract it multiply from this row and from this row to make these both 0. For what it's worth. I don't know if that's going to help or not. But we'll see. So once I get those 0, then I can look at something else. So that's what I'm going to do. I don't know. So what I want to do is I'm going to have to subtract this 4 times. Okay? In order to get this to be a 0. In other words, that 4 right there, I want it to be a 0. I have to subtract the number 1 4 times. So I'm going to multiply this by 4. And negative 48. Okay? Now, I never said it'd be pretty, but let's just go with it. So now I've got 1, and I'm going to keep this row the same. I'm going to mess it up, but I'm just going to remember that it's multiple by 4 is up here. So here we go, negative 8, negative 6, negative 12. 4 minus 4, awesome. 4 minus 4 is 0. That's really all I was shooting for. Everything else is going to come out pretty ugly. Okay, remember we're subtracting, so 4 minus 32 is plus 32, so I get 36. Okay. 1 minus negative 24, that comes out 25. And 24 minus a negative 48, 72. Okay. Put in that last row. Okay, so we've taken 2 steps, and we've got 2 out of the 9. So we're making good progress. We're essentially keeping track. If it takes much more than 9 steps, then we're probably doing something wrong. Okay, because each step should get us 1 closer, and if we're lucky, we'll have one of those steps where we get a kind of 2 for 1 deal. Okay, I'm going to do the same thing here. But I'm going to multiply this by 2. So 2, negative 16, negative 12, negative 24. And I'm going to subtract these numbers up here from these numbers here. Essentially, that's twice this first row. And that'll make this a 0. If I get anything else in the process, then I'm just lucky. Up here, I'm going to just... And I can't emphasize, and there's a chance I will make a mistake doing this. And I'd love for you to be able to chime in live and say, hey, Mr. Massey, you just totally messed that step up. But it's kind of a one-way deal here. So if I mess it all up, I can just delete this video and I'll start over with another one. That's how it's going to roll. 2 minus 2, 0. Okay, negative 4 minus negative 16, that's going to give us 20, right? Oh no, I just about made a mistake. So this is negative 4. Negative 4 minus negative 16 is negative 4 plus 16. Negative 4 plus 16 is 12. 12. Okay. Here we have 1 minus negative 12. 1 minus negative 12. 1 plus 12, 13. 0 minus negative 24. 0 minus negative 24 is 24. Okay. So there we go. we've 3 steps, 3 columns, or 1 column down, and let's see where we can go from here. I suggest, what am I going to suggest? I really don't know what I'm going to suggest here. Let's see, let's see what makes sense and what's easy. It just seems like we can make this a 0. Of course, we're going to want to move this row down to the last row by subtracting 3 12s. 3 12s, 36 minus 3 of the 12s would make that 0. I'm game. Let's see what happens. Okay, so I'm going to keep the top row Now what I want to do, and this is going to look kind of tricky, is I am going to essentially multiply this bottom row by 3, and then I'm going to subtract, right, take this row, I'm going to subtract 3 times this row. I'm also going to move it to the bottom and make this so this middle row will become the bottom when it's done. That makes this third row becomes the middle row. Now it's confusing. But it's all going to work out. Okay, so here's what I'm going to do. I'm going to, underneath here, I know that 3 times 0 is 0. These zeros aren't going to be affected. It's just these 3 numbers, so I'm okay with that. I also know that this is going to be 36, and 36 minus 36 is 0. Okay, this is going to be 39, and 25 minus 39 is, I'm going to go with 14. Okay, and then 24 times 3. 24 times 3, 72. And 72 minus 72 is 0. How awesome is that? Okay. I think we've made some real progress here if I haven't made a mistake. And, doesn't look like I've made too big a mistake. Who knows? I can get this to be a 1 simply by multiplying by 1/14, right? And that tells me that my z is 0, right? Because none of this stuff's going to change. Let's see, I gotta get this negative 12. Okay, so one thing we could do is, knowing that z is a 0, is we could plug that in here, and we've actually got reduced this to a linear combination problem, which, since these are already additive opposites, we've got a pretty easy solve. But let's keep going, because we're just having too much fun, and I know you don't want to leave it off there. So what can we do now? We want to make some zeros, right? We want this to be a 0, we want this to be a 0, and we want that to be a 0. So let's try to work that out somehow. If I take this row, this last row, which is really pretty simple now, and I add it 6 times to this, the cool thing is I'm not going to change this. I'm not going to change this. That's going to be a 0. That's not going to change. Okay, because the only thing that's going to change is that I'm going to multiply this by 6, add it up here. I'm going to have 1, negative 8, 0, negative 12. Okay, everything else can be the same. 0. Okay. Likewise, if I multiply this bottom row by 13 and subtract from this second row, then I've got another piece of cake going there, because the only thing that's going to affect is that 13, not going to affect this 12 or that 24. Right? So we're going to go 13 times this, we're going to subtract it from that, and nothing's going to change except that's going to become a 0. Okay. I'm going to multiply this middle row by 1/12. And it's going to make that a 1. It's going to make that a 2. Okay? So here we go. 1, negative 8, 0. Negative 12. We're dividing this as 0, 1, 0, 2, 0, 0, 1, 0. Okay, so now we know the value of our z, we know the value of our y. We could easily take these numbers at this point, put them back in the original equation, we figure out what x is, but why do that? I'm going to take this row, this is going to be my final step, I'm going to take this row, I'm going to multiply it by 8 and add it. Okay? It's only going to affect this number, and then I'm going to end up with 16 that I'm going to add to negative 12. It's going to get me a 4. So this first row, I'm going to see if I can stretch up just a little bit. Okay, that almost helped. All right, let's yeah, I'm gonna just cover up the original problem. We'll go back. Okay. Okay. So I said we're gonna multiply by 8 and add up here. So nothing happens there. That becomes 0. Still stays 0. Becomes 4. Okay, and essentially that's our 9th step. This is where we started. So step 1, 2, 3, 4, 5, 6, 7, 8. 9 steps. We got 4, 2, and 0. Let's go back to our original problem. And what we want to do is just make sure that this works. Okay, so 4 times 4 is 16. 4 times 2 is 8. 16 and 8 indeed is 24. Remember, z is 0. Then we have 8 minus 8. 4 times 2 is 8. That's 0. Hold your breath. We got 20. 5 times 4 is 20. Minus 8. 20 minus 8 is 12. Remember, z is 0. So this works. Really want to make those regular parentheses. This is essentially a 3-dimensional coordinate point is what that is. 3-dimensional coordinate point. Okay, and that's how you do this Gauss-Jordan certainly there's several steps in here, and I think if I was really doing this myself, there's probably a point, certainly once I figured out that this z was a 0, I'd have plugged that back in, and then I would have had a system of equations where, you know, essentially it's two variables and I've got three equations to choose from. And let's just go see what that would look like. So this is kind of bonus here. We're probably one of the longest videos we've done. We'd have 4x plus 4y, 0 is 24. 2x minus 4y is 0. And I wouldn't have even included this last problem in there, because at this point I can simply add these two. Those cancel out, and I've got my x value. So now I've got an x value, I got the z value, and I could quickly calculate that the y has to be a 2 to make that work. I could check it in the other equations, and you know, I'd be done. So there you go. That's at least one way to get through problem 19. And yes, this is the longest video. This is probably, it's not, I don't want to call it the hardest problem, but it's probably the problem that's going to take up most of your time. Even if you go with the more straightforward method of elimination, you might be able to cut the time in half. You know, this one's going to take you a little bit of time, so just, you know, when you get to it, just know that, okay, this one's going to take a little bit of time. If you want to save it for last, save it for last. Make sure you get the other problems taken care of. And it's all good. It's not a hard problem, it's just a long problem.